Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Alright, grade 12. This is a grade 12 September exam, okay, from the Eastern Cape Education Department. So here they say an electrochemical cell, cell P, consists of half cells A and B, assembled under standard conditions. The two half cells A and B are shown below. Nitrate solutions are used as a electrolyte in the cell. Okay, so what we got here is definitely an electrochemical cell, which is also the other name for a galvanic cell. Okay, which is usually in your matric paper going to be question 8. So we're kind of doing a bit of exam prep here at the same time. Okay, an electrochemical cell is also another word for the galvanic cell, so take note of that. Okay, now they ask you, one, to define a term. So usually, or most often than not, they'll ask you to define a term first in your in the first question of this section. And the term they've asked us to do there is electrolyte. Look at how they have mentioned and structured out the half cells for A and B. They've given you in cell notation. Okay, you can see something goes from solid to aqueous solution, and then we've got PT, platinum. X2 is a gas, okay, and we've got X minus in aqueous solution. So we should exactly know, we should know by looking at the standard table of reduction potentials, okay, exactly what is going on there. Okay, what is obviously gas X, okay. But they ask us later further on in this question to go ahead and determine by means of a calculation. Okay, which is, you can see on the screen, is 8.4. Okay, but before we get to 8.4 and we all get scared out of our socks, let's have a look at 8.2 first. Write down one standard condition needed for half cell B, but not needed in half cell A. Okay, that's a question that's going to stretch the brains here. Okay, and then 8.2.2, what is the function of platinum in the above cell? Okay, may or may not have looked at that last week, but don't worry, this is also a learning moment, and why I like doing exam questions as a to go through, because we can learn some extra stuff that possibly we don't see in the notes, or that maybe I neglect to cover. We can go ahead and extract that information, of course, and we can learn it. 8.3, the tin electrode is connected to the negative terminal of the voltmeter where the cell is functioning. Is tin SN, tin, the electrode, the anode or the cathode? Okay, something I think we can all answer. And the initial EMF of the cell is 1.5 volts. Identify X2, gas X2, by means of calculations, which is using the calculation formula we used last week of anode minus cathode. Okay, to get what the value is, of course, of X minus over there, or X2 gas, sorry. Okay, so let's give these couple questions a crack. Okay, I will check where we all are after about a couple of minutes and mark what we have, and then allow some time to go by for the rest, and then we'll go through it. This should take us 5, 6, 7, 8, 9, 10 minutes. So I'm going to give about 10 minutes, but I'll check in at 5 where we all are at. Okay, cool. Okay, let's look at the first question, how to define an electrolyte. Anybody would like to define an electrolyte for me? So I think this is 8.1.1, which is 8.1.
It's a substance that produces an electrically conducting solution.
Excellent. A substance that produces an electrical conducting solution. Okay. Okay. So to put that into, or I'll just put that down in my own way. A solution or liquid dissolved substance. Is a substance obviously dissolved in it? That's how it only way it can be a solution. That conducts electricity through the movement of ions. Right. Sweet. Okay, that was an electrolyte. I think it's 8.2.1. Okay, they ask for 8.2.1. Name one standard condition for half cell B but not needed for half cell A. Okay, because half cell B is obviously different for A. Okay, so the reason for this one, or the answer for this one, is that because we're dealing with a gas, okay, it's one of the there's 3 standard conditions, of course, but using this one especially, that is not needed for A. This one is not needed for half cell A. Okay, is that the pressure must be 1 atmosphere. That's P, sorry, atmosphere. I forgot how to spell atmosphere. 1 atmosphere, ATM, or basically pressure must be at 101.3 kPa, which is kilopascals. Okay, pressure must be of the gas at that. Okay, and then 8.2.2, okay, is they asked in the question, sorry, the function of platinum in the above cell, in other words, the function of platinum at half cell B and the function of platinum in half cell or in the electrochemical cell A of A and B, is that, well, half cell B contains obviously a gas there, so we need to have some type of electrode. Okay, so platinum is a conductor of electricity. Okay, so that should have been, if you put that, or you took that as a little bit of a guess, then okay, congratulations, well done. Okay, it's a conductor of electricity, that's why it's needed also in half cell B. Okay, we could fit in 8.3 here as well. 8.3, the tin electrode is connected to the negative terminal of the voltmeter. Is the tin electrode the anode or the cathode? Anybody? Yeah, Zuleika said anode, and Matthew also said anode. Sorry guys, I was waiting on the audible answer there. Didn't check the chat there. Is the anode indeed? The negative should have helped you out there. Okay, 8.4 said the initial EMF of the cell is 1.5 volts. Identify the gas X2 by means of calculations. Okay, cool. So let me choose a new layer here. 4. So obviously the formula, EMF of the cell is equal to the EMF of the cathode minus the EMF of the cell, of the half cell at anode. So we got 1.5 here is equal to oh, they're asking us for X, right? So we'll just check what is it for. Identify the gas X2. So I want to just check if I can write down X2 there. No, I can't. So let me just write this one. I realize now that I can't. Minus, of course, the value there of tin, which is obviously the anode, so that's oxidation, is obviously minus 0.14 according to the standard table of reduction potentials. Alright? So we're going to have obviously plus over there, so that's going to equal, of course, E of the cathode plus 0.14. Okay, that's going to be 1.5. Okay, so that's going to go all the way to the other side for a minus, and therefore the EMF of the cathode is going to equal about 1.36 volts. 1.5 minus 0.14, 1.36 volts. So if we find that value on the, obviously it's positive, so we find that value on the standard table of reduction potentials, we'll find that therefore the gas X2 is equal to Cl2, or chlorine gas. Okay, they didn't specify that you had to give it in the name, or if you had to give the formula. So if you said Cl2, sorry, that's the way I got the exam from. Cl2, or if you said chlorine gas, or if you gave both answers, so Cl2 in brackets chlorine gas would have been right. Okay. Did we all get this? Yes or no?
Yes, I did.
Awesome. Okay, cool. Okay, there were 2 more questions that obviously couldn't fit in the screen. But 8.5 says the salt bridge is now removed from the cell. after the cell was functioning for some time. What effect will this change have on the voltmeter reading? Choose from either increases, decreases, or becomes 0. Let's give a reading for your answer. And then 8.6 says another cell Q is set up under standard conditions. And then they give you cell Q there, obviously in cell notation, the full cell there in cell notation, anode and cathode. And write down the balanced equation for the net overall reaction that takes place at cell Q. And I will give about, I'll give 10 minutes for it in general. And then, even though it's only 5 minutes worth of 5 marks, sorry, I'll give it 10 minutes. Let's answer the 8.5. They ask, give a reason for your answer for if the voltmeter, sorry, I dropped my pen, will increase, decrease, or become 0 after the salt bridge is removed. Okay. Let's see at 8.5. So, who had an answer there for 8.5? Anybody like to share?
It will become 0.
Alright, some said become 0. Okay, 100% it will become 0. Why is that, Zuleika?
Because the salt bridge completes the circuit, so if it removes, the circuit will be incomplete.
Thank you. Alright, awesome. So salt bridge completes the circuit, that is its function. So if you remove that function, the circuit will be incomplete. So we can just write that part there. The circuit will be incomplete. Okay, will be incomplete. And then of course the ions can't flow. So then there'll be no electrical current generated. 8.6. Okay, we had two different. We had a different cell now, cell Q, and with magnesium and aluminium. So they gave us the shorthand, or not shorthand, but the cell notation for it. So we can see that this, by the way it's written, that is the anode. So you have Mg becomes, we don't have to write this in for now, but I mean like Mg 2 plus, this is probably aqueous solution, plus 2 electrons. And then aluminium one was Al3 plus 3 electrons, and that gives us of course Al solid. Okay, they asked for the net equation. Okay, so of course you're going to multiply, all right, the first one by 3, okay, and multiply the second one by 2, okay, because you need to get obviously these values to change. So if you do that, so we can obviously get the 2 and 3 that's imbalanced now to get them balanced. So if we do that, multiply by 3, we'll have 3 mgs, 3 mg2, 3 mg2 plus 6 electrons there. If we have 2 here, let's use this one, 2 Al3 plus 6 electrons here plus 2 Al solid, and of course these will cancel. Okay, these will cancel. So everything on the right gets written, so that's all on the left hand side gets written. So 3 Mg solid plus 2 Al 3 plus in aqueous, alright, gives you the top one, 3 Mg2 plus in aqueous solution plus 2 Al or in solid. Okay, that's the net overall equation, and that I think was for, you got 2 marks I think for the equation itself, balanced, or 3 marks for that, and mark for your reactants, products, and balancing. Sorry, so mark for reactants correct, your products correct, and that it was balanced. Those were your 3 marks there. Let's have a look at maybe just another one, just so we can brush up, okay, and strengthen this this section before we move on, I think, confidently and more confidently to the sorry, what's the word I'm looking for? More confidently onto the electrolytic cell, because that's going to change. It is slightly, of course, different. So question 8 here, they give us a diagram. In the previous question, they didn't give us a diagram. The previous paper. This is also the 2019 September mock exam as well. Again, we got half cell A and B here. We got the diagram of a galvanic cell setup according to standard solutions. Okay, write down the functions, or 2 functions of a salt bridge, and not 1 this time. Okay, like I said last week, it's very easy to just remember that salt bridge completes the circuit, but then they might pull a fast one on you like this. Write down 2 functions, so you got to understand it. Which half cell, A or B, contains the cathode? Okay, and that would obviously have to be you have to use your standard table of reduction potentials to solve that question. Write down the balanced equation for the overall net cell reaction. Calculate the initial EMF of the cell, and then it says the Br2 Br minus half cell is now replaced with the iodine half cell at standard conditions. I think I can get the question in here. Yes. No, I actually can't. No, I can't get 8.5 in complete. So let's just do up until 8.4 quickly. So that's 4, that's 7, 8, 9. Oh, there you go. 10 minutes for this. So same story, 10 minutes. We'll mark, we'll have a look at 8.5. So let's go ahead and answer. Question 8.1 says write down the 2 functions of the salt bridge. Now, I'm going to write down the most obvious one. Okay. Paper 2, 2019, September. 1 completes the circuit. It's the most obvious one. Now, there's 3, but you got to write down any 2. Okay, I'm sure most people would obviously remember this one because, well, it's cool. What would be the second one, or another one? Anybody? Anybody else got another reason?
It separates the electrolytes so that it
Excellent. Separates, I think that's how you spell separates, or is with the A, I'm not sure, but separates the electrolytes so that they don't mix. Tried to get away with that, but I obviously couldn't. Mix, or another way, they keep the reactants separate to allow for indirect transfer of electrons. And of course, another one which I'll use here is they keep, or it keeps, sorry, the 2 half cells neutral. Okay, so either one or any of these 2 of the 3, any 2, you'd get the mark for it. Okay. 8.2, which half cell, A or B, contains the cathode? Okay. Yes, it actually is half cell A. Okay, the way you could obviously have determined that would be by looking at the standard table of reduction potentials. You've got bromine there as a liquid, Br2L, so it's a liquid though. Okay. And of course you got iron, Fe3+, so you would look at the standard table of reduction potential and to be able to answer that question. So which one contains the cathode? It's definitely half cell A.
JP, I sort of did it a bit differently.
Sure, go ahead.
So I noticed that for the half cell A it was bromine, and then became a bromine ion, negative ion. So I realized, so that's being reduced to an ion, and the ion is being oxidized to Fe3+ ion.
That's also,
and we know that oxidation is an anode, happens at the anode, and reduction happens at the cathode. So
well done. Excellent. Okay, just using some logic and some intuitiveness to also solve the question. Okay, of course, taking note of a very key thing here, showing that that becomes ionized, and then iron becomes oxidized to Fe3+. Okay, so seeing that that is being reduced. Okay, it's gaining electrons. Okay, fantastic, excellent. 8.3, write down a balanced equation for the net overall cell reaction. So for this one, I'm just going to go ahead and write down the two half cells. Okay, but I do need a table of reduction potentials first. Let me just get that out quickly. Okay, I've got it. So I'm going to use table 4, because I know the cathode, so I'm just going to use table 4A quickly and see if I can find. Yes, okay, I found it. Okay, so the reaction or half reaction of half cell A. Okay, I'm going to need another layer for this. Okay, is just make sure of it. I think this is definitely the right one. This is 8.3, sorry. Br liquid plus 2E tends to 2Br minus. Okay, so that gets reduced. Okay, and then of course oxidizes the Fe3 plus. So I'm going to use the table 4B for this because all my oxidation reactions are on top, so I can find it much easier. So I've got Fe solid is going to be reduced to Fe3 plus 3 electrons. Okay, so what I'm going to need to do here in order to get me a net balanced equation is I'm obviously going to have to multiply again the top by 3 and of course the bottom multiplied by 2, so I can sort out this little error here. So when I do that, if I take away these numbers, they're all going to become one number. So multiply by 3, so I'm going to have 3Br. Sorry, is that Br2? Yes, sorry, that's Br2. Let me just write Br2. 3Br2 there, 6E, and of course that's going to be 3 times 2, that's going to be 6Br. Okay, and then again for the 2, that's going to be 2Fe. And then of course you got your 2Fe3 plus and 6E, which obviously those two cancel. Okay, to write out your final, usually you write the oxidation and then the reduction, so I'm going to write the oxidation of half cell first. 2Fe plus 3Br2 goes to 2Fe3 plus 6Br minus, and that's your balanced equation, and that's for 3 marks. Okay, 1 for reactants, 1 for products, and 1 for balancing. Okay, 8.4 I think was the question on calculate the initial EMF of the cell. Okay, so if we calculate the initial EMF, okay, so I wrote this at the wrong place, there we go, and we've got cell that is equal to obviously the cathode minus anode. Okay, so we don't have this, we're trying to calculate it. So the cathode, if I look there, that is positive 1,07. Okay, minus the anode there is a value of what is it now, minus 0,06, minus 0,06, which becomes obviously a plus. So therefore the EMF of the cell must equal to 1,13 or 1,13 volts for this galvanic cell. Sorry about that, pen dragged on it. Let's have a look at 8.5. Now 8.5, I'm only going to give about 3 minutes to complete before we come back and just have a look at it. They say here that the Br2 or the bromine half cell is now replaced with an iodine half cell at standard condition. Will the ammeter reading be higher or lower than or lower when iodine is used? Explain the answer by referring to relative strengths of oxidizing agents involved. Take note of this question, grade 12s. They're not just asking you to say whether it's high or low and then give a reason, any old reason. They're asking you to refer in your reasoning to the strengths of the oxidizing agents. If you do not refer to that at all in your reasoning, no matter how right you may be, maybe you refer to the half cell potential differences values. That's not correct. You don't want to do that. Okay, so make sure you refer to the relative strengths of oxidizing agents that are involved. That it's not as difficult as you think. Okay, so think about that. 3 minutes, and then we'll have a look at this question. So why don't we just take a scroll down here to the standard table of reduction potentials, okay, which is surely linked to the back here. Let's use table 4A. Okay, so we find that originally we had the bromine half cell here. So I'm just going to try and highlight for you. And we see that's got an EMF value of positive 1,07. They say that half cell was replaced with this one over here, which is the iodine one. And we see that's also positive, but it's positive 0,54. Now, although the EMF values are obviously different, we don't want to make reference to the EMF values, but we can definitely use it to help us. As you can see for table 4A, as we go up the table, there is an increasing ability in oxidizing, or increasing oxidizing ability as we climb table 4A. So bromine is higher up on the table than iodine. So in our question, if we go back to our question here, they ask us, will the ammeter reading be higher or lower? Explain by referring to the relative strengths of the oxidizing agents involved. Okay, how would we write that question out? I'll show you. It's pretty easy. Okay, first of all, the answer would be for 8.5. It would definitely be lower. Also, iodine has a lower EMF reading than bromine. But how we'd say that is lower because bromine, or Br2, is a stronger oxidizing agent than I2, or iodine, which, like I said, is not as difficult as you think. Okay, you just need to make sure you mentioned that phrase, oxidizing agent ability, all right, or oxidizing ability, because they're asking the question, refer to the relative strengths of the oxidizing agents that are involved. Okay, remember, oxidizing agent would work with your reduction. Okay, so possibly iodine would still have remained at the cathode. Okay, but reducing agents work with oxidation. Sorry. So those two terms obviously are used intertwined. Okay, so that was that question. And so far we've practiced 2 years worth of mock exam papers with regards to the galvanic cell. As you can see, these questions are not very difficult once you understand, all right, everything that goes that has to deal with the cell itself. The redox part is easy. In other words, to be able to identify which half cell is anode, which half cell is cathode, bring them together, of course, and then write a net equation. That part I think is easy for you, and I think it's easier for most matrics. But in terms of getting to know the cell itself, that's maybe a little bit difficult. But as you can see, it's not hectic questions, guys. Even this question, which is 2019, not hectic questions. It really isn't. So I have no doubt that once you guys, or not once you guys, but you all know how to use the table very well, both tables, or just pick one and stick to one. If you want to be like me and use both, by all means, go ahead. And of course, never forget which is anode, what happens at the anode. Never forget the cathode, what happens at the cathode. Never forget how to calculate the EMF of the cell. So you can, even if they give you the EMF of the cell, you'll be able to calculate the values of either the anode and the cathode. And also just read your questions very, very carefully, especially with 8.5's question, which was refer to the relative strengths of the oxidizing agents involved. This is about it, guys, with regards to questions on the cell. Okay, it's not really difficult. It is very much doable. Questions range, the mark range from about 13 to about 16 marks in general. Okay, question 9, I'll just give you a sneak peek quickly. Question 9 is the electrolytic cell. We start with this next week. Okay, we start by getting to know the electrolytic cell, taking down some notes on it. We won't aim to maybe do exam question on it, but maybe if we get to the point of doing an activity in the session next week, we'll give you an activity to do for homework, and then we'll come back and look at it maybe the following week. But question 9 is a bit of a shorter question, but sometimes these questions can be a bit more confusing if we don't fully understand what is happening in the cell, because it's different. Okay, cool. Okay, cool. Yeah, that's about it. Thank you all for joining me tonight, grade 12s. It was lovely going through the electrolytic cell questions with everybody. Next week we come and we, like I said, we touch on the electrolytic cell, and then we'll do the same method, look at exam, look at activities, everything. Eventually we'll do both questions in a final paper once a final paper is available.